All right, so thank you. My name is Thomakos. That's my name spelled without any spaces and what I go by on the internet, in case you want to find me anywhere. And I'm going to be talking about productivity engineering at Strava, which is the company I work for. So for those of you that don't know, Strava is a social network for athletes. We let you compare, analyze, and do really cool things with GPS, heart rate, power meter data, any kind of data that you might collect on during a physical activity of your choice, like a run or a ride or a swim. So I'm a trail runner myself. I have a dog named Barney who runs with me. And I've been working at Strava for a little over 8 years. And I'm currently the only full-time engineer that's a productivity engineer at Strava. And I'm part of a larger group called the platform or infrastructure team. But before I kind of get into the details of how that works and how the productivity engineering came to be, I want to tell you a little bit. I want to tell you a little bit about how productivity engineering even came to be at Strava. Because I've been there for 8 years. When I started at Strava, there were 3 of us that were developers, and I was obviously not a productivity engineer at that time. My first project was building the self-registration sign-up flow. Before that, you had to email the webmaster, and they would manually create an account for you. So as you can imagine, we obviously did not have a productivity engineering team at that time. We had a single Rails app that did everything. We took the site down completely when we deployed. We outsourced almost all of our operations, and we had very few tests. And today, we still have a Rails monolith, but it's deployed twice a day with 0 downtime. And we're a lot more service-oriented than we used to be. We run Cassandra and Redis and other persistence data stores along with our MySQL shards. We've adopted Scala as a second language. We run almost all of our services in Docker in a Mesos cluster in Amazon Web Services. And we have fully automated CI and QA suites and services. And a lot of this work can be attributed to platforms and ops and productivity engineering teams. So I'm going to tell you a little bit about how we got from that one Rails monolith to this sort of like service-oriented, I don't want to say panacea, but we still have things to work on, obviously, world. So when we first started out, like I said, we had this large Ruby on Rails application. We were running a very early version of Ruby. It was like Ruby 1.8.6 and a very early version of Rails, Rails 1. And today we run Ruby 2.3. We're in the process of migrating between Rails 3 and Rails 4. And if you've never done a Rails upgrade before, I can tell you 2 things. It will take you a lot of time, and it will take you a lot of sweat and tears to get through that process. And we've always aimed to do this process while we continue feature work, and in a very backwards compatible way. And this was great because it meant that the final upgrade was small and it was well contained and well tested. But it also took a lot longer than if we just had everyone focus on that one upgrade for a few weeks. So I've been responsible for most of these upgrades in our frameworks. And this is typically a task that you might associate with a productivity engineering team or a platform team or some kind of tool team. And I'm guessing this is sort of the same situation that hopefully some of you find yourselves in, where you're in very small startups and you just kind of have to do the work because it needs to get done. And oftentimes framework upgrades in particular are product or security driven. You need to get to framework X because you need library Y, and library Y is no longer supported on framework X-1. But I think that they're actually good productivity engineering arguments to be made for doing framework upgrades, because by upgrading all of your libraries and upgrading your dependencies in a consistent way, you can move more quickly. You can take advantage of all the performance improvements that library maintainers are putting into their software, and you can take advantage of the security upgrades that are coming, and you can just find more resources about your framework and about your libraries. So at this time, obviously at Strava, for a lot of these upgrades, we didn't have a productivity engineering team, but we were kind of doing productivity engineering related work in the background. We had a similar situation with our deployment pipeline. We started out with Engine Yard, which is this, at that time, was kind of a thin wrapper on Amazon Web Services. They managed our database and our load balancing and did a lot of deployment for us. We eventually migrated to Amazon Web Services Classic and then VPC, and now we basically run everything inside of Docker containers and Mesos. And a lot of these upgrades were due to the ops and the platform team simply improving our security and improving our infrastructure, again, because we needed it, because we needed to support services, or because we needed to support new features. And again, this is probably a situation that you will eventually find yourself in as your startup starts to grow and kind of hits that middle road where you've got services, maybe you're adopting microservices or something, and you just need to keep revving on your deployment platforms because you need to get more done, because you can no longer take the world down to do a deployment. You need to do zero downtime deployments. Like a lot of these decisions are often driven just by product needs and not by engineering for productivity. So it's likely that you'll also develop some kind of command line interface that allows you to deploy, or some kind of web interface that allows you to deploy, like Spinnaker. And we did the same thing. We developed this command line interface that allows to deploy. And again, a lot of this work was done before we had a productivity engineering team at all. But I actually spent about a quarter of my time one year migrating all of our deployment infrastructure from deploying directly to Amazon Web Services EC2 instances to using their code deploy service that allowed us to do rolling deployments. And during this time, I made a lot of changes to this script, and I basically spent my entire time for a quarter working on this project. And at that time, I was obviously doing no feature work, and we were starting to sort of push the boundaries of actually needing a productivity engineering team or some sort of tooling team, simply because I was a developer no longer doing feature work. A similar thing happened with continuous integration in QA. We kind of continued iterating on this infrastructure because we needed it, because we needed tests to run more quickly. When we first started out, we had this Hudson and Jenkins setup, and we ran all of our tests in a single job, and that job started taking upwards of 20 minutes. And we said developers can't keep waiting 20 minutes for their test to pass. So during a hackathon, I developed this Butler continuous integration service that we now use. It was originally a thin wrapper around Hudson and Jenkins, but then eventually kind of consumed the Hudson and Jenkins responsibilities. And it was really during the development of this service that I went from spending the majority of my time doing feature development to spending the majority of my time doing tooling and support for other developers. And it was kind of obvious at this point that we needed some sort of team to handle this work. And at this point in time, I hadn't thought of productivity engineering as a thing. So at that time, I lobbied our CTO and I said, I want to create a DevTools team. And the goal of this team is going to be responsible for deployment and framework updates and continuous integration. And basically all those developer workflows and developer experience things that I've been spending the majority of my time doing so far, I want to spend all my time doing it so far because there's still a lot that needs to be done. And this worked quite well for about a year or a year and a half. I did a lot of Ruby upgrades during this time, continuing to iterate on our deployment and continuous integration infrastructure. And although it wasn't called productivity engineering at the time, this was really the first iteration of our productivity engineering team. But at least for me, I kind of had a problem with the word tools. And this is a bit of a branding thing for sure. And maybe it's not something you need to think about, but for me, it was kind of important. The term tools feels very limited and it feels very reactive. A good way to think about this is, a particular project that highlighted this for me was iterating on our, or improving and streamlining our code review process. So at Strava, we use GitHub and we use pull requests to do all of our code review. And at least the tool is the same for all of the teams, but the problem is that we have a lot of cross-pollination. So an Android developer will create a pull request for the Ruby code base because they need a new API action. And the problem is that every single team had its own conventions around how we handled style violations, how we handled nits, what the process was for asking someone to review your code, how many iterations you needed to go through, when code was actually settled, how that code was merged, and when it was actually deployed. And all of these little things just kind of increase the cognitive load for anyone working in any separate code base besides their primary code base. So a lot of the project was to talk to all the teams, find the best practices we had, come up with a process, have a doc, present that doc to the rest of the engineering organization, and eventually build it into our bootstrapping process so that any new engineer that joined the company knew exactly how to review code and author code in any project across all of Strava. And if you think about it, none of this actually involved creating any tools. It was all documentation and presentation. And this was sort of one of the turning points for me, where I realized that tools was just a little too limiting for a team, as a team name. So the idea of improving productivity has a much clearer impact, I think, on organizational and company-wide initiatives. Productivity is much more forward-thinking than tools. I think a lot of productivity engineering is tools, but there's obviously a lot of cultural and process improvement involved in there as well. So the overarching principle of this rebranding of the DevTools team as the productivity engineering team was that we were going to focus on long-term productivity. And that basically means that our goal is to allow people to do more with less. And the benefit of that is that employees now get to spend more time on high impact and interesting work rather than menial and grunt work. The problem with just rebranding as productivity, though, was that we kind of lacked a framework. And productivity is a rather broadly defined concept. And a framework really allows everyone else in the organization to have insight into what your roadmap is and how you make decisions. So at that time, I came up with this thing called developer productivity engineering, which is sounds very similar to site reliability engineering, which is what it's based on, which is the Google framework for applying engineering practices to the problems facing site reliability. The idea behind developer productivity engineering is to apply engineering practices and problem solving to the problems facing developer productivity. And certainly this can be applied to everyone in your organization, not just engineers. But the primary focus is definitely the engineering organization. So the framework can be broken down into 3 components, and I'm going to tell you about each of those next and how they work. So let's get started. The first kind of pillar of the framework is identifying productivity bottlenecks. The goal here is really to develop a rubric so that everyone in your company feels comfortable assessing productivity bottlenecks. It's important that everyone can really begin to think in a more structured and more rigorous way about what productivity is and where the productivity pain points in your organization are. So a kind of a naive heuristic we might develop here is that duplication is bad. Like if we do something twice, we shouldn't do that. We should just automate it instead. But I think one of my favorite quotes from Sandy Metz is that duplication is far cheaper than the wrong abstraction. And I think that as she quite wisely pointed out, blindly deduplicating is often worse because doing so leads to bad abstractions. So when you prematurely develop tools or processes or services, you often end up developing the wrong processes and the wrong tools and the wrong services, and you end up spending more time maintaining that automation than you would have if you just did the thing manually in the first place. So we've instead chosen to use a term directly from site reliability engineering called Toil to assess productivity bottlenecks. And Toil generally means menial or grunt or repetitive work, but again, we wanted a bit of a rubric that was a little bit more structured. So we have a set of 6 characteristics. Again, they're borrowed from site reliability engineering, but the definitions are slightly adjusted to focus on productivity and finding productivity bottlenecks. So I'm going to go through these next to show you just kind of how easy this is to do. So the first criteria is that the task needs to be manual. And this might seem obvious, but if a human is not actively involved, it's probably a task is going to have to reach a much higher bar before we want to invest additional automation and effort into improving that process. So a very manual process is very easy to see, but this can also apply to existing automation. So if I have a continuous integration service that has a lot of non-deterministic tests that I need to keep checking back on and restarting, that's actually still a very manual process because I'm involved in that process and I need to keep checking on that automation. So the key component of this is really active developer wait time or active developer involvement time. The next is that the task to count as toil really needs to be repetitive. And this can be anything from once an hour to once a quarter. The frequency doesn't matter so much as the fact that we need to keep doing this. So if we did something 5 times, but we are never going to do it again, it doesn't really count as repetitive for our purposes. Repetitive really means that the task is going to be ongoing, and as long as we want to continue gaining benefit from this process. Next, we need to be able to envision a way that the process can be automated or improved. So we really need to have, we might not have the technology or the manpower to automate something, and that's okay. For tasks like that, we just can't really consider them as toil because they're out of our reach. But as long as we have some sort of ideas or some sort of thread that might lead us to an automatable solution, the task can still definitely be considered as toil. The task also needs to be tactical and not strategic. So tactical tasks are interrupt driven and they're reactive. They happen in reaction to something that is measurable and detectable. An example of this is scaling up the number of containers you have based on CPU load. CPU load is easily detectable, and scaling application containers is a very reactive and tactical task. Excuse me. Strategic things are fun. So how can we engage our users further? So we might have metrics for engagement, but how we react to those metrics can be wildly different every time. And the outcome of that process is a very strategic one rather than a tactical one. It's not very reactive and it's not very interrupt driven. Next, the task needs to provide no enduring value. The main question we want to ask ourselves in these cases is, does the task provide a permanent improvement? So if I have to keep doing this process over and over again to achieve a same or similar result, then the task does not provide an enduring value, and it's probably a good candidate for automation. And finally, it helps to know if this task is going to scale at least linearly with growth. So as we add more engineers, as we commit to our code base more often, as we try to release more frequently, is this process going to get harder to manage and harder to deal with? So those are the 6 criteria. And just to kind of beat this over the head a little bit, I'm going to give you a little example from my own work that demonstrates how easy this is to do. So at Strava, we have an iOS and Android application, and we release both of these applications in 14 different languages every 2 weeks. So each release is called the train, and there is an engineer who is dubbed the train conductor, and she's responsible for making sure that the release gets from cut all the way out to production. And the process is, or was at least, wildly complex. We used a pretty large multi-page README document that described all the different responsibilities of the train conductor, and it required a lot to get a train from cut all the way to production every 2 weeks. This diagram is kind of a high-level overview of some of the process. There's actually there should be a lot of arrows popping out of this about all the different like Slack communications that you also manually need to send out to let people know that all the different parts of the process are working as expected. But I want to take a look at just the beta building part of this pipeline. And the beta is the binary version of an application that we ask QA testers to test before we actually do a final release. So a beta can be built for a few different reasons. It gets built when a train first starts, so every 2 weeks. It gets built whenever we import new translations for one of the 14 languages. And it gets built whenever we introduce new fixes or cherry picks into the branch. So if there's a critical bug fix that needs to get in before the next 2 weeks, we need to rebuild the beta and ask beta testers to test that beta again. So we can combine a few of these actions together to maybe release a beta only once a day instead of like 3 times a day. But these are still definitely like very visible triggers that sort of trigger this process. Once the binary has been built, we include some notes for our beta testers about what they actually need to test. We manually upload this binary and the notes to the Apple Store or the Google Play Store. We release it to our beta testers. We send a Slack notification to tell all the PMs and all the other engineers what's happening. And by the time this whole process is done, you're ready to go home for the day. So it seems like a pretty easy process to assess as toil. It's definitely manual, right? The train conductor checks out the Git branch. They have to manually build commands on their machine. They have to manually type stuff into Slack. It definitely counts as a manual process. There's active developer wait time involved. It's certainly repetitive as well. We have to build a new beta at least 3 times in a release, possibly more. And we're going to have to continue to do this process if we want to release our applications. There's no getting around like building a beta and having a QA tested. It's also automatable, or at least we can envision a future in which it's automated. Even if we can't automatically detect the triggers, we don't need a human to build a beta, right? We can have that done on a build machine somewhere. Notes can be imported. There are gems that integrate with, there are Ruby gems that integrate with the Apple Store and the Google Play Store, and Slack bots are a thing. Slack has an API. We definitely don't need to do that manually, right? So we can envision an automated future for this task. It's also tactical, and this might not seem obvious, but tactical will seem obvious. The train conductor runs this process when we start, when we import translations, and when we have bug fixes or cherry picks. So these are definitely easily detectable things by a computer. This is definitely a tactical task. The part that might not seem obvious is that this provides no enduring value, right? Just because we're changing the bits and bytes on a computer's phone, on a user's phone, does not mean we're providing that user with enduring value. All of the enduring value has been provided by the feature work and the coding and the design that has gone into building the features in the first place. The actual release process has no enduring value. We're just changing bits and bytes on someone's phone. The same applies for any kind of like deployment or release pipeline process. All of the enduring value and the hard work has happened in the feature development. And finally, this scales at least linearly with growth. As we have more bug fixes, we're going to have to do this process more often. If we want to release once a week instead of once every other week, we're going to have to do the process twice as often. So it's clearly a very toilsome task. So that's it. It's actually quite simple as long as you have those 6 criteria sitting in front of you. And we try to have a little bit of flexibility in the interpretation of the criteria. The key component that we really focus on is the human time spent doing something. By no means do you have to hit every single criteria for something to be considered toil, but it definitely helps. And identifying these productivity bottlenecks using Toil is something that everyone in your organization should feel comfortable doing, not just engineers. This is one of the cases where having more data and having more inputs into your process helps. So one of the best ways that I have personally found to get at Toil and get people to tell you about Toil is to talk to them. So that means a lot of one-on-ones. It means a lot of surveys. It means a lot of attending meetings where developers are talking about development tools and about development process and about testing. So at Strava, I send out surveys, and this is an example of some of the questions I sent out. I'm in this particular case, I'm asking developers to help me identify parts of the mobile release process that are particularly bad. Of course, this is also part of, I also talk to people directly aside from just sending surveys. So a survey is a great way to start a conversation and follow up with people afterwards. So we have this heuristic called Toil for identifying productivity bottlenecks. The next thing we want to do is we want to be able to show the success of our team. We want to be able to think about ways that we might be able to measure productivity to justify why this team should actually exist and that we're actually doing an effective job. So I thought about this for a while, and I was thinking, can we measure productivity? And is that even the right measure of success? And I came to it didn't take me very long to figure out that if you try to just ask people to track time, it just sucks. Tracking time sucks. Tracking time for productivity is even worse. Tracking time sucks because it's tedious and it's inaccurate. Tracking productive time is inherently impossible because productive tasks are inherently highly varied. If I write documentation, if I mentor someone and teach them something, or if I learn something on my own, that can be a very highly productive task, but it's impossible to boil down to a single metric. And the gains from that task may only be realized so far in the future that it's impossible to tell at the time that I actually perform that task if it's a productive task or not. The other issue with attempting to measure productivity directly is that productivity engineering is a single team, or your development tools team is a single team. And there are a lot of other factors that are impacting productivity. If an engineering manager inspires one of her reports to do a better job at code reviews or learn something new, and all of a sudden that engineer's productivity shoots through the roof, you can't attribute that to your productivity engineering team. You can attribute that only to the manager. So having some higher level tracking of time and productivity is just impossible because there are too many confounding factors. So instead of trying to measure productivity directly and move that KPI, we've chosen to measure productivity indirectly. And that basically means we measure toil. So we measure the bottlenecks and we try to reduce those instead. And using that assumption, we assume that everyone is actually more productive because they're spending less time on toilsome tasks. And this also means that by focusing on toil, we allow our engineers and our coworkers to focus on the tasks that they feel will have the highest impact and that they're most interested in engaging with. And that's a much more fun and productive way to work. So the key question we ask ourselves here is, how much time are we actually spending on this toilsome task? And again, this is a case where one-on-ones help and surveys help. So I send out these quarterly surveys at Strava that I nag people to fill in. And this is a great time where it helps me track the effectiveness of the productivity team. But it also includes questions that ask engineers to estimate the amount of time they spend on specific tasks. And I send out more specialized versions of these surveys whenever there's a particularly large project that I'm interested in automating. So this is a sample of some of the questions I sent out asking developers to gauge how much time they spend on the train conducting process that we talked about earlier. So as you may have noticed, a lot of this data is based on surveys, and surveys are not 100% precise. People are bound to answer questions. They might answer a 10 just because they're super frustrated with the process. So it's important to continue to ask questions and continue to follow up and continue to test your hypotheses about why a particular task might be reported more highly than others. But using surveys and talking to people is actually highly effective for trying to gauge how much time we actually spend on tasks. So the other thing we do aside from measuring and estimating toilsome tasks is that we measure all of our existing automation. And by virtue of being automated, it can't just be classified as manual. So it's really important to get high fidelity data here. If a continuous integration service is running and it runs for multiple hours, but it's running overnight and it's ready in the morning when I need it, then it doesn't matter that it takes a long time. But if I have a continuous integration suite that's running and I need to wait for that to finish before I can merge to master, that is actually an active developer wait time. And it's something that we should consider as measurable and actionable automation. So this is a snapshot of a graph that tracks the total number of tasks running in our continuous integration service and the maximum amount of time spent in the queue, i.e. when the task's not actually running. And this is kind of an overview, but the backing data to this is much higher fidelity, and it allows me to pull out all the scheduled jobs that people aren't actually waiting on so that I can get an actual estimate of how much time people might be waiting on tests. So it's important to keep your data in a format that allows you to pull out the actionable active developer wait time data from the scheduled data that's kind of running overnight that no one cares about. So we talked about identifying toil, and we talked about measuring toil and how that can help you measure success. The final pillar of the developer productivity engineering framework is prioritizing your efforts. So the reason this is important is because we want to provide everyone in the company insight into our roadmap, and we want them to feel comfortable with the reasons why we're prioritizing one task over another. And the main thing we do in this case is we always try to align our goals with the business goals and the business needs. And those should be the tasks that we're focusing on first, the tasks that have the highest impact on our overall business goals and needs. But we often have multiple efforts that are all directly or indirectly contributing to those overall goals that we have set for our company. So we want to try to still be able to prioritize those. And the way we do that is that we calculate the savings of automating a particularly toilsome task. And the way we do that is we calculate 4 costs. The first is the cost of toil, and we always set this in terms of developer hours per week. So I spend, or our development engineering organization spends 5 hours per week on toilsome task X. That's the first cost. The next is the implementation cost. And this is the cost for an automation service, is the cost of designing, implementing, and releasing a feature. And it's a fixed cost, it's a one-time cost, but calculating this tells us how long we will need to wait before we start seeing gains from our automation. And there's actually two numbers for this. One is the amount of time it will take us, like 80 hours, and the other is the number of weeks it will actually take us to implement the solution, so that we can calculate the toil costs we're still losing during that time. And finally, software is not free. It takes maintaining, so we need some sort of estimate of maintenance for this new automation. If I'm developing a simple command line script, the maintenance cost might be a lot lower than if I'm developing a massive distributed continuous integration service that integrates with Slack and GitHub and Bitbucket and a whole bunch of other services. So this cost needs to be strictly less than the toil cost for anything to be worth even tackling in the first place. So comparing these savings over time, calculating the toil, implementation, and maintenance costs, and comparing the relative savings of two tasks can tell us which one we might want to focus on first. This savings calculation also helps us determine if a task is worth pursuing at all in the first place. So if we aren't going to see savings from automating toil for 10 years, then this effort might not be worth investing in yet. We might want to wait for the process to get worse. We might want to wait till we have more developers and it actually becomes worth building a tool for it. The final other cost we like to account for is the onboarding cost. And the main question we ask ourselves here is, how long would it take for a brand new engineer to feel comfortable owning this process? Because you don't want any one person to be solely knowledgeable and responsible for a process. Knock on wood, if someone gets hit by a bus and they are the only person who's responsible for that service, you are SOL. So onboarding cost is definitely super important. And again, this is something you can ask people in a survey. How long does it take an engineer? How long does an engineer need to be working at my company before they can participate in the on-call rotation? How long do they need to be working at my company before they can redeploy the website? Improving and simplifying tasks with a high onboarding cost will make everyone more productive in the long term. So I've also experimented with trying to measure stress or uncertainty around processes because these can contribute to process difficulty and they can be a good indicator of a high onboarding cost. These are definitely metrics I want to continue to experiment with and include in my prioritization efforts. And I think the important thing here is that you're just always testing and iterating around the questions that you're asking people. So that's the framework that I developed for the productivity engineering team at Strava. Because everyone in the organization can identify and prioritize and help understand how toil is measured, everyone is at least somewhat comfortable with the roadmap decisions that the team makes. So being able to literally say that you could hire an extra person with the time that you saved from automation is a very strong argument for why your team should exist in the first place. And those opportunities do not come around all that often, but there are plenty of other ways that the framework also helps. So reducing toil means that your workforce is happier, and a happier and more engaged workforce is more likely to stay around. So there's a good argument in productivity engineering for retention and for employee retention. And as I said, developer productivity engineering is a great way to sell a team in the first place. I think that I would have had a much more convincing argument earlier on for a dev tools team if I'd been able to use this framework to explain how my work was actually going to help the engineering organization at Strava. So I wanted to spend a little bit of time at the end of this talk looking at how we actually structure the productivity engineering team. As I said, I'm a team of one, which means that we're a pretty lean machine at Strava. And I speak about myself in the third person a lot. So I think there's sort of two ways you can kind of think about structuring a productivity engineering team. And the first way is sort of the classic team. And this is the one I quote unquote kind of ownership team. And the idea behind this team is that you maximize ownership. You own your continuous integration service and you own your deployment service. And when developers want to make changes, they talk to you and they file a JIRA ticket and you prioritize that on your roadmap and then you deliver on that product. And this is how most engineering teams work across everything. And it's actually a great model. But we've chosen to take a slightly different approach at Strava. And we use a model that I like to call a hub team. And the key of this is collaboration. These teams are much smaller, and they're much more effective earlier on in an engineering organization's life cycle. They don't even require full-time commitment to get going. So the core idea here is to minimize ownership. That means that I want to make my continuous integration service open to everyone. They should all feel comfortable contributing code to it and making improvements to that service. This means that engineers can develop their own implementations to solutions instead of depending on one team to do all of the work. And this might sound chaotic and counterproductive, but the other side of this coin is that I want to maximize communication with a hub team. A perfect example of this occurred relatively recently as we started to develop more automated style checking for our code reviews. So our Ruby team, our Ruby teams would all use Rubocop, and they had their own rules set up for that. And our Android team used CheckStyle, and they had their own rules set up for that. But by communicating with the productivity engineering team, we ensured that the interface to both of those tools was identical. The way it interacted with our continuous integration service was identical, so that any developer coming from Ruby to Android would understand that their automated style checking would happen in line, for example, in their pull requests. And any Android engineer would have that same expectation when they went over to a Ruby code base. And that means that if the iOS team decides that they want to have automated style checking, they can do that however they want. They can set up the tools however they want, but they need to integrate into a larger developer experience that we've set up for that kind of tooling at Strava. And this also means by maximizing communication and minimizing ownership, that teams can actually take on some of the productivity engineering work themselves, and they can focus on their most toilsome tasks rather than depending on the productivity engineering team to do all the work. So obviously this won't always work. It'll work for a lot of things, but some projects like continuous integration services in particular quickly become large. And at Strava, I'm hoping that the productivity engineering team will continue to grow beyond one person and inevitably will own more and more of the tooling and the automation that we have at Strava. But my hope is that as we continue to grow, we can still continue to operate more as a hub team and less like an ownership team. A recent example of this is we're taking our massive Rails monolith and moving it from Amazon Web Services code deploy to a Dockerized deployment in Mesos and Marathon. And the team of engineers that's working on this is composed of myself from productivity engineering team, but an additional 4 to 5 engineers from the platform team. So I'm by no means the main contributor to that project, even though it's a large initiative within our organization. So that's what I have for you today. And hopefully this story has helped you think about productivity and engineering in a different way. And maybe there's a little bit of the framework that you can take back to your own companies. Again, my name is Thomakos, and I work at Strava. And thank you. Happy to answer questions or talk afterwards too. Yeah.
So how many people work at Strava?
We have about approximately 60 engineers and upwards of 130 total employees. I don't know the exact numbers now. Yeah.
So 130 engineers.
60 engineers.
There are 60 engineers, 130 people. Also, you were saying that you're the only productivity, but it seems to me that within your talk, really you're not the only productivity engineer. You're a productivity engineer who has minimized your ownership as much as you can, so it can really help. So really, you're one of many people.
Yeah, I think that's the point too. Like the total number of hours that we spend on a weekly basis focused on productivity engineering tasks is much higher than 40 hours a week or more if it's a busy week for me. It's just that I'm the only person doing that full time quarter to quarter. So there's a continually changing roster of productivity engineers at Strava.
Does the monolith model of Ruby really slow you down a bit at all?
No, we have a lot more services now. So especially for a lot of our like computationally intensive or stream processing related tasks, we use other languages and other frameworks. But the Ruby on Rails monolith has been good and bad. I mean, I think one of the largest problems with it is just that as with most old code bases, it has a lot of unpaid technical debt and cruft in it that's developed over time.
Is that what do you use Scala for?
Sorry?
Did you say you use Scala too?
Scala. Oh, Scala. Yes, sorry. Yes.
Scala. Okay.
Yeah, Scala is for a lot of the back-end services. We don't write any front-end services in Scala. Yeah.
Does that help?
Yeah, it helps. It helps to have a separation between the two. Absolutely. We still obviously have a lot of back-end computation happening in Ruby just for legacy reasons, but we tend to, if we're rewriting something, to rewrite a back-end service in Scala and a front-end one in Ruby and Rails.
Thank you.
Yeah. Yes.
So the 60 engineers, do they include the engineers who work on these services, like your stream processing services, as well as your front-end engineers, or what?
Yeah, that's it. That's everyone.
So I'm curious to know what the operations model is. How aware are your developers about the operational characteristics of the code they're writing?
They are quite aware of them, I would say. Yeah.
Do they carry pagers, for instance?
Yeah, so all of our Ruby on Rails developers carry a pager. Although that doesn't page for certain events, there's a separate rotation of platform engineers that get paged about database or backend service events, and they're sort of the first line of defense. And then if there's something that's particularly related to the Ruby on Rails code base, they'll page the Ruby on Rails person as well. And that first line of defense, again, is not the responsibility of that person is not to resolve the issue. It's just to kind of triage it and pull in the correct parties that will help resolve the issue. Yeah.
I'm curious to know if you see your productivity engineering efforts sort of start to span some of that. You could imagine that the amount of time spent triaging, and if, the bulk of the time they're passing the issue off to some other team. Is there a way you could streamline that? Is that something you would consider within the domain?
Yeah, absolutely. Yeah, I think as long as, and this is a pretty broad definition, as long as it's helping developers do more with less, as long as it's helping them be more productive and, like you and Mike both mentioned, reduce their cognitive load, then absolutely it falls within developer productivity. We just tend to think about the framework of Toil to help us think in a more rigorous way about it. If we get 2 pages, then it might be a toilsome task, but it just might not happen often enough for us to think about improving our monitoring, automated alerting. If we get a lot more pages, obviously we're going to determine if those pages are actually critical, but if they are, then we're going to start figuring out ways that we can automate that process to reduce the overall the overhead for engineers. Yeah. It's more of a function of we just don't have the same kind of capacity as 1,000-person engineering company. So we have to be pretty careful about what projects we actually take on. Yeah. Yes.
You talked about low ownership, high communication in the hub model. And then you used the example of style of the different teams. And you seem to imply that the different teams spread over maybe languages kind of actually, it's not that there's low ownership, it's that each of the teams actually own their style, right? So my question is if you had a team that for whatever reason, maybe idiomatically, they were just we're not interested in owning style, it's not something we care about, but that affects other people's productivity, how do you resolve that inconsistency where it's net negative for everybody who's not a, let's say, Perl developer, but for the Perl developers they're we actually don't care about that and we're not going to fix it, so sorry.
Yeah.
So I guess 2 questions. A, and I picked style because it was the one you mentioned, but does that ever happen? And then how do you resolve that if it comes up? Those kind of competing things about where do we spend our productivity efforts?
I think a lot of that often comes down to the personalities involved and how convincing they are in their arguments. But there's definitely a spectrum. I can't say that we'd end up on one side or the other. If the Perl developers spend 100% of their time in Perl and everyone else writes Perl 1% of the time, then the Perl developers probably get to choose how they do that. Even if the rest of us are going to be a little less likely to write Perl because of those style violations, and it's going to be a little less productive for us. But if the Perl developers are just so much more productive that way, then they kind of have a case to make for running things their own way. Yeah. Does that answer your question?
Yeah.
Okay. Yeah.
are you able to identify when people sort of don't do the right thing to avoid toil? So for example, I don't want to write that additional integration test because the integration testing system is flaky. And instead of running it and it fails, I'm going to check and run it again. I just don't write that test, right? So you don't see the toil because I haven't done it. I haven't done it because like I perceive there's going to be toil there.
Yeah. So we probably miss cases like that for sure. But this actually came up the other day because the Android team was like, should we even write tests? Like we're not hitting any bugs. And I was like, well, you actually have a lot of tests. Like you have a whole QA suite and all this other stuff. And we had a pretty interesting conversation about that. And it was just, it was exactly that case. I think that like being present in person for as many of those discussions as you can is when those kinds of decisions are going to come up. Yeah. And that I'm unfortunately, that's all I have for like, that's the most effective way I've been able to get at that information. Yeah. Yeah.
Have you given any thought to how you scale as your company grows? You have more and more engineers and you go from 60 to 50.
Yeah, I think the largest problem with having a single person still in that case is that there's too many other people to communicate with. So what I meant by scaling the hub team was really that, you know, having 5 people in an organization of 100 means that we can all attend different meetings and we can all talk to other people so that we can we'll still own a larger part of the code base and a larger, maybe more tools, but we will have more representatives on more teams, continually talking about productivity and having the other teams actually think about productivity. Yeah. Great. Thank you.